Technology from the Department of Electronics and Communication Engineering. Today I am going to explain about Z transform from the subject of digital signal processing from the unit of discrete time signals and system in the frequency domain analysis. Now first of all, what is Z transform? Z transform means it is a technique for analysis and design of discrete time signal and discrete time LTI systems. Now this is basic process in which we are converting any discrete time signal from time domain into the Z time. Now what is the basic requirement to find the Z transform? The basic requirement is this, that if we are converting any signal from time domain to any another domain, means if we will use any transform technique, then we can easily do some mathematical operations on that, and as well as we can find whether the given sequence is which type of sequence it is, whether by closure or it may be non-closure or it may be finite or infinite. It can be found by using transform techniques, and we will also use the transform technique to find out whether the given system is stable or not. So basically we are using Z transform for that. Now for checking the stability we will use ROC. Now what is ROC? ROC means the region of convergence. Now what is the meaning of region of convergence? It's a region in which the system is particularly considered as a stable system, then it is considered as a region of convergence. Now how we finding the region of convergence? Suppose if we are taking the input sequence as x of n, and from that if we are finding its x of z, then in the answer of x of z we have to see that for which values of z, x of z should be finite. So if we are taking the x of z as a finite term, then it will consider as a stable system. So for the stability we will see the value of x of z for which value we are taking the z, for which it will give you x of z as a finite value. So if we are defining the ROC, then it is considered as it is the set for all the values of z for which x of z attains a finite value. So if it attains a finite value, then and then only it will consider as a stable system. Now what is the significance of this ROC? Basically we are using this ROC to find out whether the sequence is of closure or non-closure. Means to find out whether the given system is which type of sequence, closure or non-closure, and finite or infinite, and whether to find out whether the given system is stable or not. So basically we are using ROC to find out these two things. The first one is whether the given system is stable or not, and the another thing is to find out the type of sequence which is closure or non-closure, and finite or infinite time duration sequence. Now if we are defining the types of Z transform, there are basically two types of Z transform. The first one is one-sided Z transform. It is also known as unilateral Z transform. So what is one-sided Z transform? If we are defining the whole range, then the range will be from minus infinite to infinite. But if we are taking the one side only, then the range will be either 0 to infinite, or it may be from minus infinite to minus 1. So it will consider as one-sided Z transform. And if we are defining the for whole range, then it will consider as two-sided Z transform or bilateral Z transform. So the range will be changed from minus infinite to infinite. So if we are taking the equation for one-sided Z transform, then the equation is x of z equals to summation n equals to 0 to infinite x of n z raised to minus n. And if we are defining the two-sided or bilateral Z transform, then the equation will be like this: x of z equals to summation n equals to minus infinite to infinite x of n z raised to minus n. So basically in this two equation only the change is in the range. If we are taking the range from 0 to infinite, then it will consider as unilateral or one-sided, and if we are taking the range in between minus infinite to infinite, then it will consider as bilateral or two-sided Z transform. Now if we are defining some example based on this Z transform, then the first example is find Z transform of x of n equals to 1, 0, minus q2. In this you can see that the arrow is below this 0. So arrow will indicating the position of n equals to 0. Now in this, if we are defining before arrow, then the term will be n equals to minus 1, and after arrow the n will be 1 and 2. So what will be the range? Range will be from minus 1 to 2. So first of all, we will starting solving this example by taking the equation of bilateral Z transform. So what is the equation of bilateral Z transform? Its equation is x of z equals to summation n equals to minus infinite to infinite x of n z is to minus n. Now in this term, we will put the range as from n equals to minus 1 to 2. So the next step is x of z equals to summation n equals to minus 1 to 2 x of n z is to minus n. Now we are taking different values of n from the ranges of minus 1 to 2. So if we are taking according to that, then the next step is x of minus 1 z is to minus 1 plus x of 0 z is to 0 plus x of 1 z is to minus 1 plus x of 2 z is to minus 2. So this will be from minus 1 to 2. Now we will putting the values of this all the terms. The x of minus 1 will consider as a 1, x of 0 will consider as a 0, x of 1 will consider as a minus 3, and x of 2 will consider as 2. So if we will putting all this value in this equation, then what will be the next step? 1 into z is to minus 1 plus x of 0 equals to 0, right? So I will put 0 into z is to 0 plus x of 1, instead of x of 1 I will put minus 3, so minus 3 into z is to minus 1 plus 2 into z is to minus 2. So the next step will be like this. Now z is to minus plus 1 and z is to 1 means it will consider as z. 1 into z means z. So the next step is this term will consider as 1 into z plus 0 into z is to 0 means 1 means 0, and the next term is minus 3 into z is to minus 1 means minus 3 z is to minus 1. Next term is 2 into z is to minus 2 means 2 z is to minus 2. Now if I am simplifying this term, then the next step is 1 into z means z minus 3 by z plus 2 by z is to minus 2. 2 into z is to minus 2, it will convert in terms of 2 upon z square. So this is your final answer of z transform. Now if you want to find out ROC of this Z transform, then how we can find out the value of ROC? As I have defined, what is ROC? ROC means it's a range of x of z for which, if we are taking the values of z for which it will gives you x of z as a finite value. So for this we will defining the values of z for which x of z will attain a finite value. Now in this term, if I am taking z equals to 0, then you can see that minus 3 by z means 3 by 0, right? So 3 by 0 means it will gives you infinite term. Similarly, if I am taking z equals to infinite in this portion, so z instead of z I am taking z equals to infinite. So x of z will gives you infinite term. So these two terms are not valid, so we will removing these two terms. So what is ROC? ROC is the entire z plane except z equals to 0 and z equals to infinite. So this is your final answer with ROC. ROC is entire z plane except z equals to 0 and z equals to infinite. Now the next example is find the z transform of unit impulse signal, which is del of n. Now if we are defining some z transform for some standard signal, then for standard signal is del of n. Now if I am defining for del of n, what is z transform? First of all, I am starting this example solving by using the equation of bilateral z transform. So what is the equation? X of z equals to summation n equals to minus infinite to infinite x of n into z is to minus n. Now in this, instead of x of n, I will take the value as a del of n. So over here I am putting del of n z is to minus n. Now what is the value of del of n? Del of n equals to 1 for n equals to 0. Otherwise its value equals to 0. So only there is a one sample, so we are removing this summation, and instead of this del of n I am taking 1, and instead of n I am taking 0 because at n equals to 0 it has only value equals to 1. So instead of this n I am taking 0, so it will convert in terms of z raised to 0. So if I am putting this value, so the next step is at n equals to 0, del of n equals to 1, and if I am putting these two values in this equation, then this summation will remove. So x of z equals to del, instead of del of n I am putting 1, and instead of n I am taking 0. So z raised to 0 means 1. 1 into 1 means 1. So the final answer of x of z equals to 1. Now you can see that in this example, what is the value of x of z? X of z equals to 1. So there is not a single value of z. So we can take any value of z from the entire z range, right? Because if we are taking any value of z, then also the answer of x of z will remain 1 because it's a constant value. So what is ROC? ROC is the entire z range. So this way we can solve z transform for any standard sequence. So ROC is entire z range. Now the next example is find z transform of x of n equals to a raised to n u of n. Now what is the z transform of x of n equals to a raised to n u of n? First of all we are starting writing the equation of bilateral z transform equation, right? So I am writing like this: x of z equals to summation n equals to minus infinite to infinite x of n into z raised to minus n. Now instead of this x of n I am taking a raised to n u of n. So the next step is x of z equals to summation n equals to minus infinite to infinite a raised to n u of n into z raised to minus n. Now you can see that u of n, value of u of n is from ranges from 0 to infinite, its value equals to 1. So instead of this u of n I am taking 1. For which range? For range of n equals to 0 to infinite. Otherwise its value equals to 0. So this range will convert from n equals to 0 to infinite, and for that the value of u of n equals to 1. So the term will be like this: x of z equals to summation n equals to 0 to infinite a raised to n z raised to minus n. Now the next rule will arrive over here. Which one rule we will apply? When the summation will be there, then we will convert it in terms of a raised to n part. So this term will convert in terms of a raised to n. So the next step is I am writing this term as it is, like summation x of z equals to summation n equals to 0 to infinite a raised to n z raised to minus n. Now I have to convert this term in terms of a raised to n. So what will be the next step? Summation n equals to 0 to infinite a z inverse raised to n. So you can see that a raised to n z raised to minus 1 into n will give you z raised to minus n. Now this term we consider as capital A. So we are applying the equation as a summation n equals to 0 to infinite a raised to n equals to 1 upon 1 minus a, for value of mode a should be less than 1. So if I am applying this formula in the above equation, then what will be the equation? The equation will be like this: x of z equals to 1 upon 1 minus az inverse, because the value of capital A equals to az inverse, so I am putting this value, so az inverse. Now if I am simplifying 1 upon 1 minus az inverse, it will give you the answer as z upon z minus a. Now in this, how are you finding the ROC? ROC will find by using this formula, mode a less than 1. And if I am taking this formula, then the value of capital A equals to az inverse, so I am putting this value in this term. So the term will be like this: az inverse mode az inverse should be less than 1. Now if I am simplifying this mode az inverse less than 1, then the term will be like this: a upon z, it should be less than 1. Now if I am simplifying this further, then the term will be mode a should be less than mode z. And if I am rearranging it, then the term will be mode z should be greater than mode a. So this is your final ROC. So when I am taking input sequence as x of n equals to a raised to n u of n, then the z transform is z upon z minus a, and the ROC will be mode z should be greater than mode a. Now the next example is, if I am taking find the z transform of x of n equals to cos beta n into u of n, then what will be the z transform? As usual, I am starting solving this example by taking bilateral z transform equation. So what is the equation? x of z equals to summation n equals to minus infinite to infinite x of n z is to minus n. Now in this, instead of this x of n, I am taking this formula, that one is cos beta and u of n. So the next step is summation n equals to minus infinite to infinite cos beta and u of n into z is to minus n. Now you can see that in this term also there is u of n. And so because of this, the range will change from 0 to infinite. And the second thing is, in this cos beta n is given to you. So we can't directly find out that transform for this. So we will converting it in terms of e raised to something. So what is the value of cos theta? Cos theta equals to e raised to j theta plus e raised to minus j theta divided by 2j. So by using this formula, we can put the value of cos beta n in this form, like cos beta n equals to e raised to j beta n plus e raised to minus j beta n divided by 2. Now if I am putting this value in the above equation, then the next step is x of z equals to summation n equals to minus infinite to infinite e raised to j beta n plus e raised to minus j beta n by 2 into u of n z raised to minus n. Now I am applying the second rule, which one is, because of this u of n, the range will change from 0 to infinite. So the next step is x of z equals to summation n equals to 0 to infinite e raised to j beta n plus e raised to minus j beta n divided by 2 into z raised to minus n. Now I am separating this part in the form of e raised to j beta n into z raised to minus n plus e raised to minus j beta n into z raised to minus n. Now this and 1 by 2 is taken common part, right? Now I am converting this two term in the form of capital A raised to n. So what will be the term? 1 by 2 will be as a common part. The first summation is summation n equals to 0 to infinite. The first term is e raised to j beta into z raised to minus 1 raised to n. And the second term is e raised to minus j beta into z raised to minus 1 raised to n. Now we are applying the same rule as if we are taking summation n equals to 0 to infinite a raised to n, then we will taking 1 upon 1 minus a, right? So I am applying this rule. So the next step is 1 upon 1 minus a. For the first term, the value of a equals to e raised to j beta into z raised to minus 1. And this for second part, its value equals to e raised to minus j beta into z raised to minus 1. So the term will be like this: 1 upon 1 minus e raised to j beta into z raised to minus 1 plus 1 upon 1 minus e raised to minus j beta z raised to minus 1. Now we are cross multiplying these two terms. So the next step is 1 by 2. This step is I have written in the repeated form, because from the last step we can't take it directly. So I have written this repeatedly. Now I am cross multiplying this term. So it will gives you the answer like this: 1 minus e raised to minus j beta z inverse plus 1 minus e raised to j beta z inverse divided by these two factors multiplied by each other. Now if I am simplifying this term, then you can see that 1 plus 1 means 2 minus e raised to j beta z inverse minus e raised to minus j beta z inverse, and divide by 1 into 1 means 1, e raised to minus j beta z inverse into 1 means e raised to j beta z inverse minus 1 into e raised to minus j beta z inverse means minus e raised to minus j beta z inverse, and the last term is e raised to j beta e raised to minus j beta z inverse into z inverse. Now z inverse into z inverse means z raised to minus 2, and e raised to j beta into e raised to minus j beta will equals to e raised to 0, and the value of e raised to 0 means 1. So 1 into z raised to minus 2, the final term is z raised to minus 2. Now over here we are applying the next rule, which is if we are taking e raised to j theta plus e raised to minus j theta divided by 2, then we can take its value equals to cos theta. Because example is given in the form of cos, so we are converting back in terms of cos formula. Okay, so I am converting this term in form of cos and sin. So if I am taking its formula, then you can see that this 1 by 2 is given to the numerator. So 2 divided by 2 means 1 minus the second part will convert in terms of z inverse e raised to j beta plus e raised to minus j beta divided by 2. So this formula will convert in terms of cos beta. Similarly, we will do for the numerator part. So the next step is now next step is 1 minus cos beta z inverse upon 1 minus 2 cos beta z inverse plus z is to minus 2. Now in this you can see that if we are multiplying by z is to minus 2 means 1 upon z square goes over here. Then in the numerator and denominator, if we are multiplying by z square, then the next step is z square minus z cos beta divided by z square minus 2z cos beta plus 2. So this is your final answer of z transform of cos beta n into u of n. And here we had used e raised to j beta plus e raised to minus j beta divided by 2 equals to cos beta. Thank you.